Hello everyone, myself Ami Mehta, and let us discuss IO devices in operating system. So basically what we discuss in this video lecture is what is IO devices and how it is actually interact with operating system or how operating system manage these IO devices. So external devices that engage in input-output with computer system can be grouped into three categories. The first one is human readable, second one is machine readable, and the third one is communication. So in human readable, it is suitable for communicating with the computer user. For example, printers, terminals, video display, keyboard, mouse, etc. The second one is machine readable. So in this it is suitable for communicating with electronic equipment like a disk drive, USB keys, sensor, controller, etc. And the third one is communication. So in communication it is suitable for communicating with remote devices. For example, modems, digital line drives, etc. So this is the three category of IO devices: human readable, then machine readable, and the third one is for the communication parts. Now these devices are differ in a number of areas. For example, how they differ: they are differ in their data rate, they are different as per application, the complexity of control, unit of transfer, data representation. So they, in this way they are differ in the number of areas. For example, there may be differences of magnitude between the data transfer rates. So there may be difference in the magnitude between the data transfer rates of different devices. The next one is application. So the use to which a device is put has an influence on the software. The third one is complexity of control. So the effect on the operating system is filtered by the complexity of IO module that controls the device. The next one is unit of transfer. Data may be transferred as a system of bytes or characters or in larger blocks. Data representation. So different data encoding schemes are used by different devices. So this is how the devices differ in number of areas. Now, how actually organization of input-output function is handled. So, there are three techniques for performing I/O. So, these techniques are: first one is programmed I/O. So, the programmed I/O, the processor issue an I/O command on behalf of a process to an I/O module. That process then busy waits for the operation to be completed before proceeding. For example, this is the process. Now, what happened? That processor. So, for example, if this is a process A, this is a CPU, and this is input output of command or whatever that controller. So, process A issue an IO. Now, the processor issue an IO command on behalf of a process. So, on behalf of process A, the CPU issue an request to the IO module. Now, this process is waiting for this completion of operation, and after the completion of this input output operation, the process is again resumed. So this is the programmed IO. The next one is interrupt driven IO. Now what happened in interrupt driven input output operation? So in interrupt driven input output operation, the processor issues an IO command on behalf of a process. But now if it is non-blocking, then it processor continues execute instruction from the process that issued the IO command. It means that, for example, now let us begin with first that this is a process A. Now if it is in non-blocking state, what happens? So this is here write instruction. From this second instruction, IO command is input output request will be handled. So which is handled by CPU. But now what happened that CPU execute the next instruction, third one instruction after issued the IO command. So in this non-blocking processor continues to execute instruction from the process that issued the IO command. Now, if it is not non-blocking, it is if blocking. So this is if blocking. What happened that if blocking, the next instruction the processor execute is from the OS, which will put the current process in a block state and schedule another process. So this is process A, process B, these are in the ready state. Now this process A is running state, CPU take its turn, and what happened is that now CPU is executing the process is input output command. So from here there are some input output operation is working. Now process A will be in block state and process B will execute. So the next instruction the processor execute is from the OS, which will put the current process, which is process A, put this process into block state and schedule the another process. So there are process state diagram. That process can be in ready state, running state, block state, terminated state. So these are the various state of the processes. So while taking input output request from the process, operating system put that process into block state and execute the another ready process. So this is the scenario in if blocking process. What happen if there are error condition are there? So the nature of errors, the way in which they are reported, their core sequences and the available range of responses differ from one device to another. Now what is the concept of direct memory access? A DMA module controls the exchange of data between main memory and input output module. Okay, evaluation of input output function. How actually input output function are evaluated. So, a processor directly controls a peripheral. Peripheral devices means that we are adding some devices, extra devices. So that all are handled by the processor. Or for that a controller. Or we can say that input output controller or input output module is added. Now the IO input output module is given direct control of memory via direct memory access. So the input output module is enhanced to become a separate processor with a specialized instruction set tailored for input output. The IO module has a local memory of its own and is in fact a computer in its own right. Now, this is all about what are the various input output module and how input output function can be handled. Okay, so this is all about for this video.